Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Imaduddin Zakwan bin Muhammad Ismawi. My metric number is AA201277. Today, I will be present about the introduction of question number 2. Okay, first, flip-flop. Flip-flop is formed using logic gate, which are in turn made of the transistor. Flip-flop are basic building block in the memory of electronic device. Each flip-flop can store 1 bit of data. They are also called as sequential logic circuit. Flip-flop have 2 stable state and hence they are bistable multivibrators. The 2 stable states are high and low. The term flip-flop is used as they can switch between the state under the influence of a control signal. They can flip to one state and flop back other state. Flip-flop are binary storage device because they can store binary data. Flip-flop are age sensitive or age trigger device. They are sensitive to transition rather than the duration or width of the clock signal. They are also known as signal change sensitive device, which means that the change in the level of clock signal will bring change in output of the flip-flop. A flip-flop works depending on clock pulse. Flip-flop are also used to control the digital circuit functionality. They can change the operation of a digital circuit depending on the state. Okay, there is some of the common flip-flop are SR flip-flop, D flip-flop, JK flip-flop and T flip-flop. Okay, next I will be explain about counter. Counter are specially designed synchronized sequential circuit in which the state of the counter is equal to the count had in the circuit by the flip-flop. Counter calculate or note down the number that how many times an event occur. Counter are the crucial hardware component and are defined as the digital circuit which is used to count the number of passes. Counters are well known to us as time. Counter circuits are the best example for the flip-flop application. Counters are designed by grouping of flip-flop and applying a single clock signal to them. In simple words, the counters are those which have the group of storage elements like flip-flop to hold the count. Counter have mode. The mode of the counter represent the number of states of the cycle through heap before setting the counter to internal state. Okay, counter divided into 2 types mainly. Okay, which is a synchronous counter and synchronous counter. Synchronous counter flip-flop do not change their state in exact synchronous with the applied input clock pulse. In a synchronous counter, different flip-flop are triggered with the different clock, not simultaneously. A synchronous counter are also called ripple counter and also called serial counter. Okay, for synchronous counter, in synchronous counter, all flip-flop are triggered with same clock simultaneously. Synchronous counter is faster than a synchronous counter in operation. Synchronous counter is also called parallel counter. Okay, this is a difference between synchronous counter and a synchronous counter. In synchronous counter, all flip-flops are triggered with same clock simultaneously, while in a synchronous counter, different flip-flops are triggered with different clock, not simultaneously. In synchronous counter is faster than a synchronous counter in operation, while a synchronous counter is slower than synchronous counter in operation. Synchronous counter does not produce any decoding error, while a synchronous counter produces decoding error. Synchronous counter is also called parallel counter, while a synchronous counter is also called serial counter. Next, synchronous counter design as well implementation are complete dual to increasing the number of states, while a synchronous counter design as well as implementation is very easy. Synchronous counter will operate in any desired count sequence. A synchronous counter will operate in feed count sequence. Next, synchronous counter example are ring counter, Johnson counter, while a synchronous counter example are ripple up counter, ripple down counter, and lastly in synchronous counter, propagation delay is less, while in a synchronous counter there is hard propagation delay. Okay, this is example of application. For flip-flop, there are counter, frequency divider, shift register, storage register, bounce elimination switch, data storage, data transfer, latch, register, memory. And example of counter, frequency counter, digital clock, analog to digital converter. With some change in their design, counter can be used as frequency divided circuit. The frequency divided circuit is that which divide the input frequency exactly by 2 in time measurement. That means calculate time in timer such as electronic device like oven and washing machine. And lastly, we can design the digital triangular wave generator by using counter. Okay, that's all from me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurshafika binti Hasanizam with a laboratory AA200291. Today I'm going to present about FSM, which is a finite state machine. So state machine, also called as a sequential circuit, can be viewed as a synchronous counter with irregular sequence. So in other words, the finite state machine is an abstract mathematical model of a sequential logic function. It has finite inputs, outputs, and number of states. FSMs are implemented in real-life circuits through the use of flip-flops. So there are two types of state machines. First is Moore machine, which is the output depends on the present internal state only, and the second one is Milli machine, which is the output depends on the present internal state and also input at the in particular of time. So as I said, Moore machine, the output depend only on present states, and there are two parts present in Moore state machine. Those are combinational logic and memory. The present inputs and present states determine the next states. So based on their next states, Moore state machine produces the output. Therefore, the output will be valid only after transition of the state. So the next one, I'm going to present about register. A register is a collection of flip-flops. A flip-flop is used to store single-bit digital data for storing a large number of bits. The storage capacity is increased by grouping more than one flip-flop. A register is a digital circuit with two basic functions, which is data storage, the memory device, and data movement, shift capability in transferring data. So there is a basic shift register. A shift register is a register in which the stored data can be shifted to the left or right, or a group of flip-flops arranged so that the binary numbers stored in the flip-flops are shifted from one flip-flop to the next for every clock cycle. Important in applications involving the storage and transfer of data. Or in other words, shift register is a type digital circuit using a cascade of flip-flops where the output of one flip-flop is connected to the input of the next. They share a single clock signal which causes the data stored in the system to shift from one location to the next. So there is serial in, serial out shift register, which is it delay data by one clock time of each state. They will store a bit of data for each register. A serial in, serial out shift register may be 1 to 64 bits in length, longer if register of packages are cascaded. So the next one is serial in, parallel out shift register. The serial in, parallel out shift register is used to convert serial data into parallel data. Thus, they are used in communication lines where multiplexing of a data line into several parallel lines is required. A parallel in serial out shift register are used to convert parallel data to serial data. So next one is parallel in, parallel out shift register. So parallel in, parallel out, or in short name is PIPO, shift register are the type of storage device in which both data loading as well as data retrieval processes occur in parallel mode. So there are a few applications of shift register, which is the shift register are used for temporary data storage. The shift register are also used for data transfer and data manipulation. Also, the serial in, serial out, and parallel in, parallel out shift register are used to produce time delay to digital circuits.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nomenna bint Romano and I'm going to explain to you solution of A. First of all, I design the shape of it the way that I want it. I randomly pick number as long as it's in a sufficient number of 8 sequences. You can put the number everywhere that you want. Doesn't matter to put at top and bottom or left or right. The arrangement can be random, and for me, I design it like that so because I prefer it was made in easy way. After I have finished the design, I fill in the table. For the next state table, I fill in the order that I have designed earlier. For example, based on what I did, after 000 arrows point to 1000. So in my next state table that is in line with 000, I have to put 100. Okay, done for the next state table. Now we create excitation table. We still use the next state table that we just created, but add columns for flip-flop C, B and A. To fill in the column flip-flop, you can just use the JK flip-flop transition table. Example, for flip-flop C, you only use QC. Then same goes for flip-flop B and A. Follow Q respectively. QC present table match with QC with of the next table. For example, the first value of the first two is 0. Match it with 0. So refer to the transition table that say if both 0, to fill it will be 0x. So that's why JC and KC it's stated 0x. When I have filled it out to flip-flop A, I did K-map for each flip-flop and circle it with corresponding value. Then you can decide which gate you want to use. When I have determined what gate to use for equation we got from the K-map earlier, I draw a simple circuit for a simple understanding. and after it is ready for circuit implementation, we can connect the wires to the Tinkercad as usual based on output and input that you have made on this circuit implementation. Thank you.
Hi, Assalamualaikum. My name is Muhammad Aris. I'm gonna talk about how I will be explain how to make a Tinkercad for our experiments. To making this Tinkercad data, we have to follow the current implementation. So we have to follow it. How where we need to put our for output A QA. I use the input output 1 for this IC. For QB, I use output 2 in this IC. And for output QC, I use output 1 in right IC. For after that, we have to connect the wire and we can run it, and we will get the result. For making this logisim simulation, we just need to follow schematic diagram, and we can run it in logisim, and we will get the result like in the table. Okay, I think that's all for our team.